All right, welcome again. We continue to look at the fundamentals of precalculus, and we initially looked at real numbers, their properties, different aspects. Then we also had a look at sets and notations, just the basics, just to remind ourselves of what these were all about. We also looked at the absolute value and magnitude, distance, in other words. Here now we want to look at exponents, and this will be followed by radicals in the next video. But then these are actually very closely related, and so they walk hand in hand. That's the radicals and exponents. Okay, so this video will look at exponents, and we are going to define exponents and look at the integer exponents. We'll look at the zero and negative exponents. We also look at the we're going to look at the laws of exponents. We'll also apply these aspects into maybe trying to simplify complex exponential expressions. Okay, so this is what we are looking at in this video. So to start with, what are exponents? Okay, where do we use exponents? So exponents are used to express large numbers as powers of smaller numbers. Okay, so for example, we can have a 10,000. Okay, we have a 10,000. This can be expressed as 10 power 4. If we have another number, let's say 16, this we can express as 2 power 4 or 4 power 2. So these are exponents. And so we'll meet these as we go. So generally it's m over n, where a is a number, m is an integer, n is an integer, and then m over n will be our rational number, because m and n are integers. Remember, we defined rational numbers in our earlier video. Okay, so now what are integer exponents? Okay, these are what we've made a couple of times in our algebra. And so these are products of identical numbers. Okay, so what are these identical numbers? For example, I can have 2, okay, by 2 by 2 by 2. Okay, if I've got 2 by 2 by 2 by 2, that'll be 2 power 1, 2 power 1, 2 power 1. And then we add those ones together to get 3. We'll see what we'll see when we look at the laws. And then here we have a power n times a power m. So we have a m plus n. And this is not equal to a m n. These are two different expressions. So we have to know that. Then we look at 0 and negative exponents. These are important. Remember, if you want to be good with the bigger picture of calculus or maths, we have to know these. They help us to identify the patterns. A power 0 is 1. A power minus 1, this flips and becomes 1 over a. Okay? Then, for example, x power minus 1 also becomes 1 over x. We can also look at 2 power negative 2. Again, in a similar fashion, this is going to flip into 1 over 2 power 2. And then through that process there, and then we get 1 over 4. Okay, a quarter. And then just to, even if you have a complex fraction, anything powered to 0 is 1. So these are patterns that we have to remember. Okay, so some of the laws, we looked at the two laws already, a power 0, a power minus 1. Okay, now we look at an. Okay, so a product of these will be am plus n. So those are identical numbers. Am over an gives us am minus n. These are patterns we need to be able to remember, because we need to see these patterns when we have our complex calculus or maths. Okay, so amn becomes am, and that is not equal to am plus n again. So we have to remember that. Okay, we make so many mistakes with this. So ab power m, we're going to expand everything into the brackets, then becomes am bm. This again follows the same expansion. The m touches both of the numbers inside the brackets. Okay, all right, so a over b power 1, we said that this flips whatever you have in the inside. Okay, number 7, law number 9. Again, here we're going to have to flip what we have there. So b over m, bm over am. Okay, so those flip. Now let's go into simplification. For example, we'll do 2 quick examples here. Okay, just 2 quick examples from the book. Now, the first example is 6st minus 4 over 2s power minus 2 t power minus 2. Okay, so here we see the patterns quickly. The numbers, we separate them, the numbers. Then we see there's s. Okay, so we separate the s's. We see there's t, we separate the t's. Okay, that's also positive. Okay, then now we can simplify individually. 6 over 2 becomes 3. S over S2 becomes S1 minus 2. T becomes T minus 4 minus plus 2. So now we have 3S, 1 plus 3, S, T, 4 minus 2. Okay, that becomes minus 6. Then we have 3S3, okay, over T6. We flip that one. Okay, and then this is the final expression that we have simplified. Okay, so this is the simplest form of that expression that we were given. Okay, let's look at another expression. Okay, now you see things are coming together because we did what negatives do to each other, what negative and positive does. Okay, so now why that expression, we are going to split it into individual components. First, we put inside the square brackets. We separate each into simple expressions, okay? And then the minus 2 visits each bracket, okay? Like that. So we have y minus 2, 1 over 3 minus 2. Then we have 1 over z3 minus 2, okay? So there we have 1 over 3, okay? I've flipped them, I've exchanged them. That one becomes 1 over y2. Then the next one becomes 1 over z minus 6. Okay, now we can simplify these. That one becomes 9. That one becomes z6. The other one becomes y2. Okay, so that's it. So today we looked at the exponents. Okay, we looked at different aspects of these, beginning with the definition of what exponents were. We looked at the integers, integer exponents. Okay, then we looked at the 0 and negative exponents. Then we went on and looked at the laws of exponents. These are simple laws only. And then we also looked at the simplification of exponential functions, also exponential expressions. Okay, so you can see how small things are coming together. Let's be patient as we continue to work on these. Thank you and have a good day.